In this video, we are going to be introducing the idea of functions. Now, you've probably seen functions before, but you may not have known that that's what they were called. So I want you to think back to prior learning that you've had regarding in and out tables. So you've probably seen something like this, where there's a given input and you apply some sort of rule and it produces an output. So you think of it like a function machine, like something goes in, then there is an operation or possibly combination of operations that it's done to the input, and then some output is produced. So go ahead and pause the video while you copy down this part of a definition. So a function is like a machine that takes an input, applies a rule, and produces an output. And we'll add to that now. So the relationship, ooh, I can barely fit it. The relationship between the input and output can be described with a rule, also known as, or AKA, the function. Okay, so the function of the machine is the rule that is applied to the input to produce a particular output. Okay, so what if the rule in our machine were to be something like, right here, times 2. That's our rule. And we were to then put into the machine a 1. We put in the 1, what would pop out if times 2 were our function? Well, 1 times 2 is 2. Well, what if we were to put in a 2 to our function machine? You'd apply the function, and what would pop out? A 4, because the rule is times 2. 2 times 2 is 4. What if we were to put in a 3 as our input to our function machine? 3 times 2 is 6, so the output would be 6. What if we were to put a 4? 4 times 2 is 8, so the input is 4, and the output would be 8. All right, you get the idea. Now, sometimes the rules are multiplicative, sometimes they're division, sometimes they're addition, sometimes they're subtraction, or sometimes they're a combination. So let's just do another one. What if the rule for our function machine were to be plus 7? If we had the following inputs, what would the outputs be? Okay, so go ahead and pause the video while you try to figure out what the outputs would be, and then hit play when you're ready to check. Okay, so 4 plus 7 would be 11. 8 plus 7 would be 15. 12 plus 7 would be 19. 16 plus 7 would be 23. So now we have our input. You've applied the function or the rule to produce said output. All right, now sometimes function machines or in-out tables, they give you the input and the output, and you have to determine what is the rule or what is the function. So you'll see now how the label, instead of rule, we've used the vocabulary term function. But these are really can be used interchangeably. This is just more the real mathematical term, and then this would be what you've probably casually had it referred to as previously. You will also see we had input and output. Whereas now that we're into algebra, you'll see that these columns are often labeled with X and Y. And yes, they're referring to the variables, and yes, they're referring to the axes on the coordinate plane, which I will show you later. So X and Y. So whenever you see that, you know that would be input and output. All right, so what if we had as our input, we had, let's say, and our output was, how would we go about determining what the rule is? Well, we would go through and test to see what is the relationship between the input and the output. I could look for either an additive relationship, so or an inverse of additive, meaning it's subtraction. So 25 to 5. So I know I'm decreasing in value. So it might be minus 20. So maybe the function's minus 20. And then I would take that theory and I would test it on the next one. 35 minus 20 would be 15. So that doesn't work, so I know that's not the rule. So I need to go back. Maybe there's a multiplicative relationship. 25 divided by something equals 5. Well, 25 divided by 5. So I'm going to test divide by 5. So go to on the next one. 35 divided by 5, 7. Oh, so far so good. 65 divided by 5, yep, that would be 13. And then 80 divided by 5, yep, that would be 16. So we know our function for this table is going to be divide by 5. All right, and the last one we're going to look at today with the x and y, the input output, we're going to try to figure out what the function is. Sometimes you'll see that it is a two-part function rule. So if we put 4 goes in, what if 10 were to pop out? What if 6 goes in and 14 were to pop out? What if 9 were to go into our machine and 20 were to pop out? 13 goes in and 28 pops out. So I'd have to think, what rule can I apply to all of these combinations or all of these ordered pairs in order to produce that output? Okay, well, I could try multiplication. So 4 times 2 would be 8. 4 times 3 would be 12, so that's too big. So I know it's not going to be a simple multiplication. I can try additive. So 4 plus 6 would be 10. 6 plus 6 would be 12. So I know it can't be that. So I'm going to start thinking of different combinations of things. So maybe it's a two-step rule. So what if I were to try times 2 plus something? So what about 4 times 2? Now I'm at 8. And how many more would I need to get to 10? Well, I would need 2 more. So what if the rule is times 2 plus 2? And then I would test it. 6 times 2 is 12, plus 2 more is 14. All right, so far so good. Let's test it again. 9 times 2, 18, plus 2 more is 20. Ooh, this is looking good. 13 times 2, 26, plus 2 more would be 28. So my rule, or my function, is times 2 plus 2. All right, so I think that about covers it with functions and in-out tables, and we're going to be building on this, how it connects with algebra.